Welcome everyone in the next session of urban and suburban transportation concept, strategy and organization. In the today's session, we will mainly talk about what is right of way. And as we already explained in the previous session that we have three different type of right of way category A, right of way category B and right of way category C. Today we will understand with different figures, with different advantages and disadvantages. We will also try to understand the comparison of those three right of way as well. We will also try to understand that what is the driverless system design and its functional characteristic. So in this first slide, is you can see here, if we are talking about right of way category C, so public transportation vehicle sharing the place with other vehicles or with the pedestrian. So there is no physical separation from other traffic. Right of way category C include special lanes for buses, streetcar only indicated with the pavement marking signs or signal. As you can see here in this figure, on the left side, we have the pavement is marked with the cyclist sign. So that means that only cyclists can only use this track. So as you can see here on the right hand side, the buses and the other taxi cars are actually waiting for the signal to go green. But as you can see here, they cannot use the cyclist portion. Okay. So if we try to understand the right of way category C, so right of way basically category C is a example of a mixed street transit system, but it only work and operate in like the developed countries. The underdeveloping countries or the third world countries, they might have issues because of the traffic rules and regulation. So the in the right of way category C is, you can see here in the very first point, that it could be used by buses, trolley buses, streetcars and tramways, but they have the same sense that they will never cross or the maneuver to the other lanes, such as a cyclist lane or such as the pedestrian lane. So usually for right of way category C, we need less investment as compared to right of way category B and A, and less land can be used as well. Okay, because all the transit functions such as buses, cars, and other private vehicles and the uh, taxi, they will operate from a single lane. Okay. The street cars, tram, buses, and trolley buses, they will only use or share its place at the junctions, okay, and at the intersections. And performance is always dependent on the traffic condition, okay. We have usually in the right of way category C, we have usually the passenger stop is a bit less than 300 meters. Okay, because for the purpose why we come or we operate tramways on the right of way category C, because usually we have less demand or less design for the speed as well as for the passenger accessibility within the same area. Okay, so public transport on right of way category C is generally not competitive with private cars on the same street in terms of speed and reliability. Okay, as you can see here in the right of way category B, the roadway or the track is physically separated, such as by curbs, or only the same portion is elevated a bit from the ground surface, such as barrier or maybe green strips from the other public traffic. So public transport vehicles running independent from other transportation except at the street intersections. So those street intersection could be at a road crossing or railway crossing. Okay, as you can see here, the rest right of way category B, most of the time 80 to 90% they operated independent from the other moving traffic. So in the right of way category B, we have the medium transit system such as BRT system or light rail transit system, which actually are physically separated by buses. So the its best example of the BRT system of a right of way category B is Peshawar bus rapid transit system, which operate in Hyderabad on the right of way category C. So it's share its place, but at the University Road till the last station, Mughalpura station, so it's completely operated on the right of way category A, which is completely separated by the boundary walls or fencing. Such type of a street modes or semi-rapid transit modes have usually need a bit higher investment cost as compared to right of way category C. So performance is also better than right of way category C. So if we talk about right of way category A, so why I brought this picture? Because so just to tell you that it's completely dependent, completely independent. Okay, so public transport vehicles which are completely running independent from other traffic. So there is no legal access to the roadway, track, or to the other vehicle. Its best example is because we don't have any road crossing or railway crossing. Okay, so it's completely dependent on its own track and they have completely their own right of way. So in the right of way category A, they it's usually preferred and uses for the train transit such as metro or maybe the mass rapid transit which operate in Germany, in UK, in New York, and so on. So the BRT Peshawar is the example when it's operate on the main university road where it did not share its path with any traffic mode. Okay. So it have usually high capacity and the headway is also very little, so less than 5 minutes. Okay, and is compared to the speed, reliability, and punctuality, right of way category A have higher is compared to B and C. Okay, so it's most of the time uses for the railway technology or the railway development. Its best example of right of way category A, which is completely independent from other traffic and transit mode, is rubber tire rapid transit, which we call RTRT, which you can see in the Lyon, Montreal, Canada, and Mexico City. Okay, and it's nowadays it could be found in the Kuala Lumpur as well. Okay. So now we will understand. So this was all about to just give you the brief concept that what is right of way C, B, and A. Now we are trying to understand that if we want to compare B with C or A with B, so that to understand more in a detail. Okay. So first of all, we would like to understand that what is the difference between B and C. So if we talk about advantages of a B, because B have higher performance in terms of speed, reliability, capacity, and comfort is compared to C because C is completely shared its path with other transit mode. As you already saw in the picture that they were operated from the same lanes. And in the right of way category B, we have more train ability to patch it up. So if we have more capacity, so we can increase its capacity as well. Okay. So right of way category B have a bit more stronger identity in the eyes of the traveler. Okay. So and also we can improve its performance as well in terms of speed or in terms of the unplanned traffic as well. Okay, its operating cost per passenger is a bit lower than C because in the C the same transit mode might stay in the same lane. So at the end, passenger might get frustrated because of the longer travel time. So when we usually use rail technology in the category B, so the same modes, In the right of way category B, it's sometime electrified, and sometime it's a diesel base, and sometime it's a solar base as well. And they have a best less air pollution as compared to C, because C is most of the time hybrid, as well as of the petrol or like diesel. And because of longer delay, it emit a lot number of CO2 emission as well. So if we compare B with C, of course more space is required in B, because C is completely mixed and shared with other transit mode, while B is a bit separated through the curbs, through the green strips, through maybe the boundary lines. And of course B need more investment as well. And maybe at the intersection and the junction, most of the time we need a special priorities signal as well. So now we try to understand A with B. Okay. So if we would like to say A means completely independent, while B means it's again independent, but at the junction, at cross section, it share its spot with the other moving or the transit modes. So the major advantage of A is that it need a very high for the highest performance, highest speed, more reliability, more punctuality, more capacity as compared to B, and it have the high attraction in the eyes of the passenger or traveler as well. We The right of way category A usually operate from the multiple doors, which can handle in less than 1 minute more than 1,000 people. So you can imagine, okay? So if we compare the disadvantage of A with B, of course, right of way category A is usually completely operated from the tunnel or from the above head or the elevated bridges, okay? So because of this huge investment cost, so which make B a bit more higher while A bit more less. Okay. So if we talk about the alignment and geometry, so category B could be put in the static sense. So it could be used within the city, within the existing infrastructure. But for the A, we always maybe needed the underground stations or maybe aerial structure. Okay. Or maybe aerial structure are needed only to access category A. Okay. And category A, if we want to change it to B and C, we might need it more grid separated or more stations, or maybe we need to move for a longer distance as compared to connect B with C. So the A is a bit more grid separated, because for example, if it's operated from the underground station, so first of all you need to go out from the underground terminal, and then you need to come out, and then you need to change again to the right of a category B, which might take a bit longer as compared to B and C. Okay, so those two concepts is already covered, right of way and what is the comparison. So now we will try to understand, if we want to understand the vehicle distance or vehicle guidance, or which we call the driverless system as well. So if I would like to put it in the way as you can see here in this very specific figure. On our left side, we have the guided way, which is of course railway or maybe tram. But in the right of way, in the right figure, we have the steered way, which best example is could be BRT. Okay, or maybe light rail transit as well. So again, both of them have right of way. In the left hand side, we have right of way category A, but in the right hand side, we have the right of way category B. So most of the time they have different. So as you can see here in this figure, in this picture, that vehicle in the transit unit, which are physically led by or separated by guideway and fixed track. So we don't have any changing lane condition or no U-turn. So both of them will only follow the guided way. Okay. and those vehicle guidance option is usually used for the larger or longer vehicle, and this only operate when wherever we have huge demand of the passenger within the geographic area, and it's always suitable for the high passenger volumes. As I already mentioned, they have more capacity and lower operating cost per space per passenger, and and both of them have the high performance in terms of speed, comfort, reliability, and riding quality. And both of them, of course, needed land as well, huge land as well. Okay, so if we talk about the comparison about the guide of way or the guided way or the steered way, so one operate in the right of way category A, while another one is operating in the right of way category B and C. Okay, so if we talk about first of all the guided way, which is most of the time is right of way category A, have a bit higher investment cost, except the tramway or the streetcar, and it may involve higher uh, higher network density as well. Okay. So this is a figure just to give you idea that how the transit unit are basically operating and driving and control. So nowadays in most of the countries, it's operated its function on the fully automated, where we don't have any driver, but for the people satisfaction, they just put their driver as well. So its best example could be seen in the Nuremberg and Paris, where they have operation of manually driven and fully automated train on the section. Okay, on some of the junctions and section, there is a driver for the people satisfaction, but the driver have only control on the junctions and in the intersection, again to reduce the machine deficiency. Okay, but most of the time it's operated on the intelligent transportation system and artificial intelligence. Okay, so most of the time they are also called automatic train operation as well, which is partially controlled by the driver. So if you this is a second last slide. If we want to compare the fully automated train with the driver system, so what will be its advantages and disadvantages? So if we talk about the fully automated train operation compared to the driver, first of all, before to go in a detail, there is a lot of studies done. So the people usually they feel more satisfaction when they see a driver, so they feel they face or feel a bit more but they are kind of feeling a bit in comfort when they cannot see the driver. So it's frequently operation of a short train is feasible during the off-peak hours, because in the peak hours we might end up with issues. So we can adjust the transit unit schedule because there is a human control system behind that. But if we talk about the fully automated train, so we need a very higher investment cost in the fully automatic, because they might observe each and everything, but they may be not 100% efficient, so which reduce the human dependency on the machine system. So as you can imagine, and presence of a crew member is often desirable for the, of course, for the security purpose, for the passenger information, but mechanical and control systems are a bit more complex, in which might need more expensive maintenance as well. Okay, thank you very much. If you have any question, you can get back in the comment section. Thank you.